Hello, this is Mrs. Huntley. This is video 4 of the Pythagorean Theorem supplemental packet. The lesson that we're on right now is called Applying the Pythagorean Theorem. It should be on or about page 9 of your packet. On the top of the page, it should say Applying the Pythagorean Theorem in this kind of bold print. And at the very top, I'd like to add the essential question: how can I use the Pythagorean theorem to help me solve application problems? So that's going to be our essential question for this particular lesson. Now in this lesson, we're going to use what we learned about the Pythagorean theorem and about the proof and the converse of the Pythagorean theorem to solve real-world application problems. So those of you that are avid students might look at this page and recognize that it's kind of set up a little bit like a tutorial request form. It wants us to break down our question and kind of look at it analytically before we start to solve it. So let's read the question. Bethany has a circular tabletop that she needs to carry inside her house to paint. Her front door is a rectangle and it has a width of 36 inches and a height of 80 inches. If the tabletop has a diameter of 86 inches, will it fit through the front door? So this again is broken down. What do I know before I even start solving the problem? Well, let's think about a rectangle. A rectangle, here's a picture of a door over here. It's kind of hidden, but a rectangle has 4 90-degree angles in the corners. And if I drew like a diagonal from the top of one side to the bottom of the other side, I could use the Pythagorean theorem to figure out the diagonal distance of that door. Okay? So that's what I'm going to say that I know right now. I know a rectangle has 90-degree angles. So I can use the Pythagorean theorem to find that diagonal distance if I'm trying to carry in my circular table. Okay? So what do I need to know? I need to know if that diagonal is going to be enough so that I can tilt my table on the side and fit it through the door on a diagonal. So is the diagonal distance of the door greater than 86 inches? Why 86? Because my tabletop has a diameter of 86 inches. So now I'm going to come back and I'm going to mark up my text. So I know I've got a rectangle and it has a width of 86 inches, or I'm sorry, 36 inches and a height of 80 inches. So I'm going to draw a picture down here of my door. So I've got my door and it has a width of 36 and a height of 80. And I'm looking for this measurement right now. So I know if I can tilt that table on the side and fit it through the door. So if I do that, I know that this is going to be my right angle. That's going to be my C side. So I can use the Pythagorean theorem here to figure out what the length of that C side is. So go ahead and see if you can set up the problem with what I've done so far. I want you to get ahead of me, so I'm going to give you about 10 seconds to get it set up. Remember, we've got a squared plus b squared equals c squared. So I'm going to plug in 36 squared plus 80 squared equals c squared. And again, remember we were talking about this. If you set it up to be 80 squared plus 36 squared, that's fine. You're going to get the same answer. Order doesn't really matter when you're adding. It matters when you are subtracting, but not so much when you're adding. So go ahead and square up those numbers. 36 squared is 1,296. And 80 squared is 6,400. That equals c squared. So 6,400 plus 1,296 is 7,696. I want the square root of both sides. So the square root of 7,696 I have at 87.7268, etc. So I'm going to say it's approximately 87.7, what is this, inches. So what do we conclude about that? Okay, I needed the tabletop, I needed to be at least 86 inches. It's 87.7. It's going to be tight. You're going to have to watch your fingers so they don't get pinched. But yes, the table is going to fit diagonally through the door. through the door. Okay. The next one has it set up very similarly as far as how we analyze it. It says Greg plays baseball at a field where the baseball diamond is a square with each side measuring 90 feet. If the baseball was thrown from home plate to second base, then from second base to third base, how many feet did the baseball travel round to the nearest tenth? So I'm actually going to start this one with a picture. For those of you that are not baseball people, I am part of a baseball family. So a baseball diamond is very familiar to me. So that would be my baseball diamond. It should be a perfect square. Mine's not quite. But this says that we've got 90 feet on each side. So this is 90, this is 90, 90, and 90. This is our home plate. This is second base. This is first. And this is third. Okay, I don't know why my pen is doing weird things here. Okay, that's just for my non-baseball people. These are all 90-degree angles, even though my picture is not drawn well. Okay, so what do I know? I'm looking at this picture. What do I know? I know that a square has 90-degree angles, so I can use the Pythagorean theorem to find this diagonal from home plate to second base. So let's go ahead and bring that over. Excuse me. A square has 90-degree angles again, so I can use the Pythagorean theorem to find this diagonal to go from home plate to second base. What do I need to know? I need to know the sum of the diagonal distance and one side of the square. Why? Because the ball is traveling. I'm just going to demonstrate this. The ball is traveling from here to here, then to here. So that's why I need to add those together. So the first thing I'm going to do is use the Pythagorean theorem. A squared plus b squared equals c squared. See if you can go ahead and set up the problem using the sides of the triangle. I'm looking for the c side here. So 90 squared plus 90 squared equals c squared. Hopefully you set it up that way. 90 squared is going to be 8,100 plus 8,100 equals c squared. So 8,100 plus 8,100 is going to be 16,200. And I need to take the square root. So the square root of 16,200 is approximately 127.279. So I'm going to say C is approximately 127.3 feet. Now I need to take that 127, oops, I can write just not well right now. So the diagonal, I'll actually label this diagonal, is 127.3, and then from second to third, is going to be another 90. So 127.3 plus 90 is going to be 217.3. Okay, so my solution, the distance is about, the ball travels, right? I'm sorry, 217.3 feet. Okay, so you always want to answer a application problem with a sentence. You need to have your words in there. Okay, so you're showing your work, answering the question. Now this idea of defining what you know ahead of time and drawing your pictures and stuff like that, you don't have to do this on every problem. I'm a very visual learner. We've already talked about that. I'm very visual in what I'm thinking. Like I see pictures in my brain as I'm talking about things. So I like to jot down my pictures and label them up, especially if I'm unfamiliar with the situation. Like those of you that are unfamiliar with a baseball diamond, hopefully this helped you as far as what it looks like and where the ball would be going and that type of thing. And that's what I like to try to do with my pictures. Now, if you notice on the next page, we don't have, well, we have some room, but they don't have the same setup where you have to define what you know and what you need to know. So what we're going to do is work through a couple of these. We'll define, um, we'll mark our text and we'll define what we know and what we're looking for. And then the solutions will just be applying the Pythagorean theorem. So hopefully this will become more easy as we're working on it. So number 3 says, Melissa wants to put a ribbon border around a sign in her classroom shaped like a right triangle below. If the ribbon costs 82 cents per foot, how much will it cost her to buy the ribbon? So the ribbon border is going to go around the perimeter of the triangle. It's going to go around the entire thing. So the first thing I need to do is I need to use the Pythagorean theorem to figure out what the missing length is of my C side. Okay, so I'm going to use the Pythagorean theorem. A squared plus B squared equals C squared. Go ahead and get that set up. And again, I'm giving you plenty of time to get set up ahead of me because I want you to be working these problems. Okay, if you're just copying from me, it doesn't help you learn. So I've got 6 feet squared plus 8 feet squared equals C squared. 6 squared is 36. 8 squared is 64. 36 plus 64 is 100. Square root both sides, and C would be 10. Now, the perimeter is not 10. This side of the triangle is 10. So to find the perimeter, I've got to add 10 plus 6 plus 8. 10 plus 6 is 16, plus 8 is 24 feet. So the perimeter is 24 feet, but I'm not looking for the perimeter, I'm looking for the cost of the ribbon if it costs 82 cents per foot. So I need to take that 82 cents, this is the cost of the ribbon, .82 times 24 feet. How much is that going to cost? Let me grab my calculator. Okay, 24 times 0.82 or 0.82 times 24, I get $19.68. So it's going to cost about $19.68. Okay, an isosceles triangle. We're going to do, let me look at this. We'll set the rest up and then I'm going to have you work them out on your own. Okay, an isosceles triangle means that two sides are the same and it's not necessarily a right triangle. Okay, an isosceles triangle is not going to be a right triangle, but I can drop down a midpoint in my isosceles triangle, and now I've created a smaller triangle within the isosceles triangle that is a right triangle. Okay, my base is going to be cut exactly in half. So this side plus this side, they're going to be identical, and as far as the measurement, and added together, they're going to equal the entire base. So just explaining that about an isosceles triangle. Let's take a look at the problem. In the isosceles triangle below, the congruent sides each measure 13 meters. So this one's 13, and this one's 13. And these are meters. If the base of the triangle is 10 meters, what is the height of the triangle? So this entire base is 10. So that means this little part of the base over here is going to be half of 10, or 5. So if I'm looking at this, I've got my C side. I've got one leg. I'm looking for the other leg. So with A squared plus B squared equals C squared, I've got A, 5 squared. I don't know B, and I've got C. Okay. Just so we don't run out of time, I'm going to let you work that out the rest of the way on your own, and you will check your answer when you get to class tomorrow. Number 5 says a square sandbox in Trisha's backyard has an area of 81 square feet. So again, side times side is how you find your area, and this is 81 square feet. Find x, the diagonal length of the box. So if my box is 81 square feet, what is one of the side lengths? Okay, side length would be 9. The square root of 81, 9 times 9 equals 81, and that's the entire box here is 81 feet. Now we're looking for the measurement just of the diagonal of the box. Okay, so I'm going to use Pythagorean theorem. This is my right angle. I'm looking for that diagonal, which is going to be my C side. So 9 squared plus 9 squared equals C squared. Again, I'm going to let you figure out the calculation and check your work when you get to class tomorrow. I'm just helping you set these up. Okay, number 6. To walk to her friend's house, Julie normally walks 63 yards north and 16 yards east, as shown. So if this was on a map, this is where Julie lives, and she would walk 63 yards up one block, turn the corner, and then walk 16 yards to the next block. How many yards shorter would it be if Julie took the diagonal shortcut? So again, here's my right angle. I am looking for the C side. Okay, so when I'm setting this up, I've got an A side and a B side. I've got my both of my legs. So 63 plus 16. Okay. Again, I'm going to have you work out the rest of the problem. Check your work when you get to school. Okay, number 7. If the perimeter of square 3 is 36 units, so that means the perimeter is the distance around. This one is 36 units. And the perimeter of square 2 is 48 units. Again, the distance around is 48. Oops, I did that backward that time. 2 is 48. What is the area, not perimeter, of square 1? Okay, so perimeter is the distance around. So if I know one of the side lengths, and a square is going to have all the same side lengths, it's going to be side times, or side plus side plus side plus side. So if I've got 36 as my perimeter, I'm going to divide that by 4. So 36 divided by 4 is going to give me one of the side lengths of this small square number 3. And 36 divided by 4 is 9. So I know this side is 9. It means all of the sides are 9 because 9 plus 9 plus 9 plus 9 is 36. I'm going to do the same thing with 48 for square 2. So I know that my perimeter for square 2 is 48. Divide that by 4, and that's going to give you one of the side lengths. So go ahead and do that. Did you get 12? So now I've got my 2 legs. I can use my Pythagorean theorem to figure out what this length is. Once I know what that length is, I can find the area of that larger square, which would be whatever that length is times itself. So let's do the Pythagorean theorem. A squared plus b squared equals c squared. Set it up with 9 squared plus 12 squared equals c squared. Go ahead and solve for c, figure out what this length is, and then to find that area of square 1, you're going to take that number and multiply it by itself. Or you might recognize that you don't have to take the square root at the very end, and it will tell you what it is. Again, I'm not going to work this out to the end. I am out of time. I see I'm passing the 20-minute mark, so I am going to end here. Go ahead and try to get these 4 worked out and get your final answers. Check them in at school when you see me. Number 8 for extra bonus points. If you can figure out number 8 on your own, go ahead and figure that out. And summarizing today's lesson, we can use the Pythagorean theorem in a number of different situations to help us solve real-world problems. We're going to always go back to our original a squared plus b squared equals c squared and solve for whatever we don't know. Have a good night. See you in class tomorrow.